So hello everyone, welcome to the video. So let's first understand what is the concept of a stack. Before jumping into the right code, let's understand what a stack actually is. A stack follows the LIFO principle, that is last in first out, just like the plates stacked on top of each other in a wedding ceremony reception. Here the last element added is always the first one to be removed. This concept is heavily used in real systems like, say, function calls, undo operations, and memory management. Now, coming to the implementation, I am creating my own custom stack, public class custom stack, instead of using Java's built-in stack class. Yes, Java does have a built-in class for this. Internally, I am using an integer array to store elements. Okay, so we'll do like private integer data. Then we'll also have I'll maintain a pointer variable that always tracks the top of the stack. So private int pointer will be equal to -1. Okay, initially the pointer is set to -1 because it simply means that the stack is empty. Then I'll create a constructor, public custom stack, which will have a parameter int size. With this int size, we will initialize our integer array to the for the size of this parameter size. So basically the constructor takes the size of stack as input. Based on that size, I initialize the array. This allows me to control the stack capacity explicitly. Once the object is created, the stack is ready to accept elements. Now, coming to implement the insertion operation in a stack, we call it the push operation, starting with public boolean push int item. First, we will check if the stack is full or not. First, we will implement the utility methods is full and is empty. So public boolean is full. So when our stack is actually full, when the pointer is at data dot length -1, okay, it checks whether the pointer has reached the last index of the array. Then there is empty utility function. So when our stack is actually empty, when the pointer is at -1. Understood? So coming to the insertion operation, here before inserting I always check if the stack is already full to avoid overflow. If there is space, I will increment the pointer and then place the element at that index. This ensures that the element becomes the top of the new stack. So if the stack is full, we'll simply print stack overflow, and then what? We'll just return false. Since it is boolean, I will return false. Otherwise, I'll increment the pointer by 1 using post increment plus plus. Then data with index of pointer will store the item. Okay, now we will return true. Alright, then coming to the removal operation or the pop operation. Pop will have a return type of int, public int pop, and it will throw an exception, a custom exception that we will create in this video. It will be stack exception. If our stack is empty, then how can we pop element from it? So we will throw a new stack exception saying stack is empty. Let's create a custom stack exception. So public class exception extends class exception then public stack exception, which will accept string message, then super message. And that's how our custom exception is created. Okay, so if it is empty, we will throw a custom exception that the stack is empty. If not, then we will return data of pointer minus minus. Okay, so by theory, the pop element removes the top element from the stack. Okay, I return the top element and then decrement the pointer. This keeps the stack structure very consistent. Then coming to the peek operation. Peek is similar to pop, but it doesn't remove the element as compared to pop. Okay, so public int peek, it will throw a stack exception like pop. Okay, why? Because if the stack is empty, how can we peek into it? Isn't it so? Is empty, then we will throw a new stack exception, stack is empty. If it is not, then we will simply return data of pointer. Looks good, isn't it so? Okay, now let's make a function, display function, so we can view all the elements in the stack. Public void display. How will we do that? First we'll check if it is empty or not. If it is empty, system.out.println stack is empty. Then we will simply return. If not, we'll continue for loop int I equal to pointer, I is greater than equal to 0, I minus minus. Okay, system.out.print data of I plus space, then we will simply leave a blank line. Okay, so our custom stack implementation is done, as you can see. You can pause the video and take notes. Then, to check if it is working or not, inside our main class, we will create an object of custom stack. Custom stack is equal to new custom stack of size, say, 5. First, I want to push some elements into it. Push 10, copy, and push 20, and push 30. Then I want to see if it is really getting into it. Display, run, value of n. Oh, I am running some other program, forgive me. Current file. See, it is printing. By mistake I put here 230. It is just 30. Okay, 30, then 20, then 10. All right, good. Then for the pop and peek operations, remember we implemented a stack exception. All right, so whenever we are implementing something which is exception, we must always fit that into a try catch block. So starting with system.out.println peek element plus stack.peek. Looks good. Then system.out.println popped element plus stack.pop. Implement a catch block of error of type exception of type stack exception e system.out.println e dot get message. Alright, then we'll also again do it stack dot display, check the final output. Okay, stack final. Let's see if it's working. As you can see, 30, 20, 10, peak element is 30, then we popped an element 30, and after popping the element 30, our final stack looks 20 and 10. Thank you for watching this video. Please like, share and subscribe.